A job is sitting in the CA7 request queue right now. It's late, the SLA breach clock is ticking, and your team lead is asking, why hasn't that job run yet? If you have been in that situation and you did not know which command to fire, then this video is your answer. By the end of next 15 to 20 minutes, you will know exactly which CA7 command to use, when to use, and how to use in real production scenario. And if you stay until the end, I will walk you through a full real-world incident scenario using everything you have learned in the video, so that you can see how these commands work together. So here's a brief summary of what all different commands we're going to discuss in this video. So very first thing is the status and inquiry commands. And these commands are the one which will help you in understanding what is happening in your queues at any moment. Second one is the action commands, for example, demand, run, cancel, hold, and release. And these commands are the one that move jobs and control their flow. The third one is the audit and history commands, and these are the one that will help you to look backward, find out what ran, what failed, and what was restarted. And finally, a real-world incident walkthrough that ties all these commands together. So the very first question is, what is CA7? So CA7 is a mainframe job scheduler that automates batch processing, manages job dependencies, and ensure workload run in the correct sequence. It provides real-time monitoring, rerun, restart capabilities, and tight integration with ZOS environment. Eventually, it actually used heavily on IBM mainframe, and this product is owned by Broadcom. Now let's try to understand the CA7 queue architecture, because before you can use these commands, you need to understand where exactly these jobs reside within CA7. Of course, there's a database where you need to define all these jobs and the corresponding dependencies. But CA7 also uses different queues, and these queues are used to manage the execution of these jobs within CA7. So whenever you issue any command in CA7, it would eventually read data from any of the queue, or it will affect any of these queues. Think of it like a pipeline. A job starts in the request queue. This is where the scheduled or manually demanded jobs wait for their input requirements to be satisfied. It could be a predecessor job, dataset availability, or time trigger events. Once all the requirements are met, the job moves to the next queue, which is ready queue. It means it is cleared for execution, and now it is waiting for a CPU slot. Now, from there, it actually enters into active queue. That means the job is now running on IBM mainframe. And after completion, the job history is written to the run log, which you can query later for auditing, restart, and post-incident analysis. So, in nutshell, every CA7 command you use, whether you are checking the status, forcing a run, or canceling a job, operates within this 4-stage pipeline or queues. And you should always keep that mental model in your head as we go through each command group in our next section. Now, let's talk about how you interact with CA7. So commands are entered on the top line of any CA7 panel, and that's the area which is actually labeled as command on your terminal screen. Some environments also support issuing these commands through batch interface or automated scripts, but today we are focusing on online command interface because that is what you will use when incident happen in real time. Now let's talk about our first group of commands, that is status and inquiry commands. And these commands are used very often, and they will let you know what is actually going on. Now the very first queue is LQ, that is list queue. And the syntax is pretty simple and straightforward, that is LQ comma job equals to job name, or to see everything you can use LQ comma job equals to asterisk. So LQ is your first stop. It lists jobs currently in CA7 queue, that is request, ready, or active, and it will give you their current status. You can also filter by job name, or you can use a wildcard to see everything in flight. Now, in case if you want to see the jobs which are stuck and they are waiting on requirement, so in that case you can use LQ comma job equals to asterisk comma list equals to RQMT, that is requirement. This would eventually show all jobs with outstanding requirement, that is predecessor jobs not yet completed or user added holds or unresolved triggers. Now let's say you want to see the jobs which is there in ready queue, that is ready for execution. So for that, what you can do is you can use LQ comma ST, that is status equals to ready comma job equals to asterisk. So this would eventually show all the jobs which is ready for the execution. Now the next one is, let's say you want to see what all jobs are right now in execution mode or actually running. So in that case, what you can do is you can use LQ comma ST equals to ACT comma job equals to asterisk. So this will eventually show you all the jobs which are actively executing right now. Now these three variants of LQ, that is ready, request and active, should be the first thing you should run when you get a call saying something isn't running. Okay. Now the next command is LJOB, that is list job detail. And the syntax is pretty simple. It is LJOB comma job equals to job name. Now LQ actually give you a queue level snapshot, but LJOBs goes deeper. It shows a full profile of a specific job. That means its schedule ID, its predecessor requirements, its trigger relationship, its average runtime, and its last successful run date. A particularly useful variant for production support is LJOB comma job equals to job name comma list equals to all. So this would eventually show everything, that is condition code checking, executable status, all predecessors and successor relationships, and the last 5 run. It actually gives you a full picture. Now, if you want to check how many schedule IDs are assigned to a job, then you can use LJOB comma job equals to job name comma list equals to SCHD. That means scheduled data request. It will tell CA7 to display the overall scheduling criteria for a job. It will actually show execution days, calendar ID, and start time. Now, you need to remember that each schedule ID or SCHID represent a different run pattern for a same job. A job might run daily with schedule ID 001 and on month end with a schedule ID 050. Now, if you want to look at how a job behaves under a specific schedule, you can narrow your search by adding the ID to your command. Then your command will be LJOB comma job equals to job name comma list equals to SCHD comma schedule ID, that is SCHID equals to 001. So you should not get confused with schedule data request, that is SCHD, and schedule identifier, that is SCHID, because these are two different parameters that can be used with LJOB as per your requirement, or in case if you want to deep dive and see, okay, what exactly is the schedule for a specific job, then you can use these particular parameters to identify that. Now the next command is FSTRUC, that is forward structure, and the syntax is pretty simple. It is FSTRUC comma job equals to job name. And this command will show you the downstream dependency chain for all the jobs that will trigger after your target job completes. Think of it as looking forward in the stream. And this is critical before you take any action. So if you cancel or force complete a job without checking the downstream trigger, you could cause tens of other jobs to run or fail or to run unexpectedly. Now, the companion command is backward structure or BSTRUC. So this command will allow you to see upstream predecessor that feed into this particular job. And you should use BSTRUC when you are trying to understand why a job is waiting in the request queue. Now the next command is FJOB, that is forecast job. And the syntax is pretty simple, that is FJOB comma job equals to job name. And this command will allow you to see the scheduled future run of a specific job, right? That means that when CA7 is expects to run this job as per the calendar definition. And this is useful when business stakeholder ask, okay, when this job is next due to run, right? So probably what you can do is you can quickly go back, run this particular command and find out, okay, when this job is scheduled to run next. A broader query would be FQ job. That means it will forecast job across the entire queue for an upcoming time window, right? Both commands are essential for capacity planning and SLA conversation. Now the next command is pretty interesting. That is XQM, that is Queue Maintenance Panel. So when you type XQM, it will bring up the queue management panel, a screen-based view of the current workload. From here, you can see job listing with their requirement type displayed as flags. So if you see J, that means job requirement, that is predecessor job not yet done. If you see I, that means internal requirement. If you see E, that means external requirement. If you see U, that means user requirement. That means somebody has added the manual hold on this particular job or maybe any job. If you see N, that means network requirement. And this visual flag system help you instantly identify why a job is waiting, right? Now, let's move on to our next section, that is action commands that involve moving and controlling jobs within the CA7. Now, these are the commands that will do things within CA7, and you will be using these commands heavily during an actual incident. So, very first command is demand, that is request a job to run. And again, syntax is pretty simple, that is demand followed by job equals to job name, comma, schedule ID, where you have to provide the actual schedule ID of a job. So this command manually places a job into a request queue. Unlike the run command, which we will cover next, so demand actually perform requirement checking. That means job enter the queue, CA7 check whether its prerequisites are satisfied, and only if they are satisfied, then it will move towards the execution. So this is a safe way of manually triggering a job because CA7 still validate the input dependencies before execution. Now let's talk about a couple of common variants of this command. So let's say you want to run a job in isolation. So in that case, how you can use this command is, so you can use demand, comma, job equals to job name, comma, schedule ID followed by the schedule ID of the job. After that, you can use set keyword followed by NTR. That means no triggering. So this would eventually tell CA7 to run this job without triggering any downstream job in the stream. So this is your go-to when you want to rerun a single job in isolation without setting off a chain reaction. Now let's look at another variant where we will going to use skip keyword. So the entire syntax is demand, comma, job equals to job name, comma, schedule equals to your schedule ID, and then you have to use the keyword set equals to skip. So when you use this particular keyword, it will tell CA7 to run the job but mark it as a replacement for the next scheduled run. So the automatic scheduler won't run it again unnecessarily. Now another variant of demand command is DEMANDH, that is demand with hold, and the syntax is pretty simple. Again, you have DEMANDH, comma, job equals to job name, comma, schedule ID followed by the schedule ID of the job. Now this is identical to demand command. The only exception is that job enters the request queue with a hold on it. That means the job will not move to ready queue until somebody explicitly release it with a post command. So you must use this command when you want to manually demand a job but need to verify the JCL overrides or coordinate with any other team before executing or running this job on IBM mainframe. Now the next important command is run, that is immediate execution, no requirement check. And syntax is pretty simple. You have run keyword followed by job equals to job name. And this is a powerful tool and it must be used carefully. Unlike demand command, run actually bypass all input requirement checking and the job is submitted for execution immediately, regardless of whether its predecessor have run or its database are available. Additionally, when a job is run via run command, CA7 does not update the database upon completion. and the job triggering does not occur. The job run in isolation, no predecessor checked, no successor triggered. Now the question is when you should use run command. So you should use run command when you need to execute a job that is not defined in CA7 database. Perhaps it's an ad hoc job or once-off utility or an emergency batch process. You can also use run command when you have already verified all the prerequisites manually and need the job in execution right now without waiting for CA7 requirement evaluation. You can also use the RUNH command that does the same, but it will place the job in hold state first so that you can do a final check before execution begins. Now the next command is cancel. That means remove a job from the queue. And syntax is pretty simple. That is cancel followed by job equals to job name, comma, force equals to yes, comma, reason equals to text. So you have to provide some specific valid reason. And this command actually remove a job from CA7 Request Queue. Now the critical point that you need to understand is that if a job is already in the ready queue or actively executing, then issuing a cancel command in CA7 does not stop the job from running. It only removes CA7 tracking of that particular job. Now to cancel the job that is already in a ready or active queue, you must cancel it at a JAS level through SDSF, that is System Display and Search Facility, or you can also reach out to System Operator. The CA7 cancel command is for the request queue only, and you should always supply a reason when canceling. This creates an audit trail in the run log, which is very important in the post-incident review, right? So in case if you want to see why this job was cancelled, you can very well check in the run logs. Now the next command is ADDRQ, that is add a requirement, and syntax is pretty simple. You have ADDRQ, comma, job equals to job name, comma, user equals to reason. So there are situations where the job is in the queue and you need to add a temporary hold on it. And in that situation, what you can do is you can add a one-time requirement before it proceeds further. So ADDRQ adds a user requirement to a job that already sits in a request queue. So the job will not move forward until the requirement is posted or removed. You can very well use this particular command when you need to pause an in-queue job while a dependency is being manually resolved. For example, you're waiting for a vendor file to arrive or holding a job while other team complete a related process. Now let's talk about our next command, that is requeue, or move a job between different queues. So syntax is again pretty straightforward. You have requeue, comma, job equals to job name, comma, queue equals to queue name. So requeue actually allows you to manually move a job from one queue to another. This is typically used in a restart scenario. For example, moving a job from a failed state back into a request or a ready queue for re-execution. Now let's talk about our next category of commands, that is audit and history commands. And you know these commands are very important because incidents don't end when the job runs. They actually end when you have confirmed what happened, documented, and make sure the downstream chain is intact. And these commands are post-incident toolkits and they're very helpful, right? So very first command is LRLOG or list run log. And the syntax is pretty simple. You just use LRLOG. And this is one of the most powerful command available to production support teams. It actually query the CA7 Run Log, which records every significant event, that is job completion, force completion, restart, cancellation, and abeyance. Now let's look at different variants of this command. So first one is LRLOG, comma, job equals to job name. And when you execute this command, it will actually show a full history of a specific job, how many times it ran, and whether it completes, abandoned, or was cancelled. The next variant is LRLOG, comma, ST equals to cancel, comma, span equals to 24. So this command will actually list every job cancelled in the last 24 hours. Similarly, you have next variant, that is LRLOG, ST equals to force, span equals to 24. And this would eventually list every job that was force complete in the last 24 hours. Similarly, you have LRLOG, ST equals to restart, span equals to 24, and this would list every job that was restarted in the last 24 hours. And the last variant is LRLOG, job equals to job name, date equals to asterisk. And when you execute this command, it will show all run history of a job over the last 5 days. And you should remember that CA7 retain run log data for a configurable number of days, and the default value is 5. So finally, LRLOG is your single best tool for answering the question, what happened last night? Now let's talk about our next command, that is LPRRN, that is list previous run, and syntax is LPRRN, job equals to job name. So this command actually lists the details of the previous completed run of a specific job, that is start times, end times, completion status, and return codes. So when somebody asks when did this job ran successfully, then you can very well use LPRRN and give the answer within seconds. Now the next command is LJCL, that is list JCL, and syntax is LJCL, job equals to job name. And this command actually retrieve and display the JCL associated with a job, that is a job control language that tells mainframe what to execute and how to execute, and what are the inputs and what are the output. And during incident analysis, you can review the JCL so that you can understand what is the step sequence, what are the data set names, whether you have provided the override parameters correctly or not, because any of these incorrect value can lead to a job failure. The next command is lschedule, that is list schedule, and the syntax is lschedule, job equals to job name. And this command actually shows the scheduling definition for a job. That means which calendar it runs on, which days it's scheduled, its run out time, and its lead time. So when a job appears to have run at a wrong time or not run at all, in that situation you can use lschedule, that will let you know what exactly CA7 expected to happen. Now let's bring all this together with a real world scenario. So let's say it is 2:15 a.m. and you receive an alert. A critical end-to-end batch job, let's call it as payroll 01, has not completed. And the SLA deadline is 3 a.m. So you only have 45 minutes. So the very first step is that you need to understand the current state. So you're going to use LQ, job equals to payroll 01. So when you fire this command, CA7 will show payroll 01 sitting in the request queue with a J requirement flag set. That means a predecessor job hasn't completed. Now our next step would be find the blocker. Now in this case, we will going to use BSTRUC, job equals to payroll 01. And when you fire this command, it will show you an upstream dependencies. A job called GLExtract02 is listed as predecessor. Now you have to use the LQ command to see if it failed with an append in an active queue. After that, the step 3 would be to check the history, and for that you can use LRLOG command. So the command would be LRLOG, job equals to GLExtract02, span equals to 24. And when you fire this command, you will have the logs, and the log actually showcase that GLExtract02 appended at 1:47 a.m. with a return code that is 12, and it has not been restarted. Now the step 4 is to check the downstream risk, and for that what you can do is you need to issue a command that is FSTRUC, job equals to payroll 01. And when you fire this command, it will show that payroll 01 trigger 4 downstream jobs including a critical fund transfer batch. So you need to be careful about what you trigger tonight. Now the next crucial step is that you have to resolve the issue with GLExtract02, and for that you need to coordinate with a DBA team or the respective team who are actually owner of this particular job. So you have coordinated with them and they have confirmed that it was an issue with a table space which has been resolved now. So now you have to restart or you have to execute that particular job once again. So again, you will going to use demand, comma, job equals to GL extract, comma, schedule ID equals to 001. So when you fire this command, GL extract 02 enter the request queue, requirement check passed, and it will move to the ready queue and it begin execution at 2:28 a.m. Now, before we move to the next step, I would like to highlight or I would like to reiterate that you should not blindly restart job from the top. You should clearly scrutinize or analyze what all different steps have been executed or none of the steps have been executed. And based on your assessment, you should start either from the top or you should start from the relevant step, right? Because this is very important. However, each and every project has a specific rules and guidelines how to start a job, so you must follow that. Now our next step is monitor and confirm. So you have to use LQ comma job equals to GL extract 02 every few minutes, and at 2:41 a.m. it complete successfully. So CA7 will automatically post the job requirement for payroll 01, which move to a ready queue and begin execution. So let's assume by 2:54 a.m. payroll 01 completes. That means you have met your SLA and you still have 6 minutes to spare. Now let's talk about the last step, which is very crucial, and that is documentation. So for that, you can use LRLOG comma job equals to GL extract 02 comma date equals to *. And when you fire this command, it will show run log for this particular job. So what you can do is you can copy the output and paste it into your incident ticket as an evidence. So this is how you can use these combination of commands to fix the problem with any of the job during your production support activities. So here's a brief summary of what all we have learned so far. So first one is LQ that will help you in understanding what is there in the queue right now. Then we have LJOB that will give a full profile of any job. After that, we looked at FSTRUC and BSTRUC command, and these commands help you understand the job dependencies before taking any action. After that, we looked at demand and DEMANDH commands, and these commands are used to trigger jobs safely with or without a hold. After that, we looked at run and RUNH, and these commands force immediate execution when a requirement check isn't required. The next is cancel, and this command actually removes a job from the request queue with a reason always. The next one is ADDRQ, and this command actually add temporary requirement to hold a job in a place. After that, we looked at LRLOG. It will actually interrogate the run log for any time frame, any job, any status. The next one was LPRRN to see the previous run details instantly. After that, we looked at LSCHD and LJCL to verify the schedule and the JCL when something doesn't add up. Last but not the least, production support on CA7 isn't knowing about everything. It's about knowing the right command at the right moment. That's the difference between a 45-minute incident and a 6-hour outage. Last but not the least, if you like this video, then please leave your feedback and hit a like button, and do share this video with your friends and family member. Apart from that, I would love to know what all different commands you have used so far in your daily job. And in case if you want a deep dive into CA7 restart procedures or building automation with CA7 batch interface, then do write that in the comment section. I would certainly create a video so that you can understand how exactly these technologies or these functionalities within CA7 works together. So once again, thank you so much for watching the video.